So I'm here with Chris Turner. He was involved in the development of the BBC Micro, was Chief Engineer at Acorn. Chris,
That's right.
Thanks for your time. Got a few questions for you regarding your time at Acorn and the BBC Micro and
Okay.
your other projects there.
All right, far away.
Your time at Acorn, how did you get involved with Acorn in the very early days?
Oh well, my story goes back possibly the furthest. My first job was as a technician at the Cavendish laboratories here at the university, the Department of Physics. And I was working in the electronics group, producing all sorts of wonderful gizmos for to support the various experimental apparatus that was developed.
Right.
And Herman came to Cavendish, came up to Cambridge to do his PhD in physics. And as a research student, he came into the workshop and was scheduled to take advantage of our services to produce a box of electronics that would help him capture the data from the very high-speed cameras that he was using in surface physics experiments. And so I was appointed to work with him, and together we developed this box, which was cards full of TTL and op-amps, classic electronics really of the time, a one-off, you understand.
Yeah.
And I put that together for him, and you know, from then on, during his time at the Cavendish, he would come to me when when it didn't work and it needed adapting and so on. So this was probably 1975,
Right,
or thereabouts. So both pretty young at the time, obviously. After I'd left the Cavendish, I got my degree in engineering and electronic engineering, and left the Cavendish at that time and went to work for Pi Unicam, which was part of the Philips Group, a company here in the town that made chemical analysis apparatus, spectrophotometers. And I had some quite exciting times as a design engineer at Pi Unicam because microprocessors were just starting, so we were involved in some of the very first projects using 4040 and then 8008 and then 8080 CPUs and Intel development systems. And we worked on those things. And I also had very early experience of the Commodore PET because we were connecting at first large desktop HP calculators to the back of the spectrophotometers to analyse and compute the results, and then our marketing guys saw the PET being launched in the States, and so they actually had one shipped over that turned up on my bench, and so I think I was possibly the first user of a PET here in the UK. And that had an IEEE 488 or general purpose instrument bus connector on the back that you may remember that we connected up to the spectrophotometers, and I had to do a bit of fiddling with cables and adapters and so on, and we got that working, and some months later it was actually announced for the American market at least as an authorised accessory, as it were, for our equipment. So combined with the sort of Intel microprocessor experience, I was very, very aware of microprocessor systems and where the industry was going, and excited by it all. I then moved within the Pi companies to Pi TVT, where, quite by coincidence, I was appointed to be the lead design engineer on a project with the BBC. And this was to produce a commercial implementation of a device that had been invented down at the BBC's research department in Kingswood Warren, which was a digital noise reducer. So this was a big picture store which filtered out white noise or grainy noise from the television pictures and cleaned them up prior to transmission. And such boxes are now commonplace in the studio chain, but in those days it was very advanced, and Pi TVT won the contract to commercialise this development of the BBC's. The cost was they had to supply units free of charge back to the BBC. The upside was they could sell them everywhere else in the world. So I was building, in regular conversation with the BBC, and very cognizant of studio television engineering, how PAL television systems worked, Teletext, you know, all of that came my way, and my career was there in 1978, and then the phone rang one day, and it was Herman.
Right.
Could we meet up? Lunch in town, Copper Kettle. There was always lunch in the Copper Kettle, you understand. And he explained that he and Christopher were he was working with Christopher at Science of Cambridge, and they had this design for a computer, the MK14, but they needed help to, as it were, production engineer it.
Right. Yeah.
And I see from the other interview that you've managed to trace where some of the other elements of that design came from. As far as I was concerned, I was presented with a circuit diagram drawn on a piece of graph paper, and here are some key switches we'd like to use.
Right.
And, what's the best way to go about it? So in my spare time, I just got married, and it was a useful small amount of additional income. So at the weekend and a few evenings, I did the PCB layout for the MK14.
Right.
Rationalised the TTL logic, swapping AND gates for OR gates to get the package count down.
Yeah, absolutely. Right.
And produced a PCB layout, which I then assembled the first one of and tested, and a bill of materials and so on, and helped to see the MK14 on its way.
Right.
And carried on working at TVT, and then Herman called again and said they were starting a company called the Cambridge Processor Unit, and they had this contract to do produce fruit machines,
Right.
microprocessor-based fruit machines, and could I come and talk about that? And I remember very well going to the house in Grange Road where Herman was living at the time, and meeting Steve for the first time. Steve introduced his design, and we talked about what would go in a fruit machine. There was a fruit machine in the lounge,
right.
And
As it should be.
so we undid the back and had a good look.
Right.
And Steve produced the sort of inner circle of the microprocessor and memory core, and I chose some rack-mounted engineering electronics and built the interfaces to interface the mains. A lot of this was mains driven, so
Right.
where there was zero crossing detectors and triacs and so on. Can't remember, was it mains or was a lot of it 50 volts AC? I think a lot of it was 50 volts AC flying around inside the thing, because what we were trying to do was to initially these machines were full of CAN timers that were all clicking round and producing the odds, as it were, and had lots of relays, flashing lights, and full of wiring looms. And what we first wanted to do was to just put the box in instead of all the controls, but keep the wiring loom. But that didn't work because the power distribution and the earthing was all too noisy for a microprocessor environment. So we ended up re-engineering sort of the machine all the way up to the bulbs, lamps, and sensors and switches and everything else. So there were ribbon cables and connectors to be sorted out and all of that kind of thing. And the clients we had, which was Ace Coin Equipment, one of the leading fruit machine producers at that time, headquartered in South Wales, they were pleased with what we were doing, and the contract went through subsequent phases, and Herman asked me if I could come and work full time, which I did on I think the 1st of February 1979. So resigned, made the big decision over Christmas, and resigned from High TVT, and served my month's notice, and then started at the beginning of February. I was the first employee of the Cambridge Processing Unit, which was, as it were, the parent company to Acorn initially. First of all, Acorn was a brand name of Cambridge Processing Unit, and then it got set up as a separate company, and then of course eventually Acorn became the parent of CPU, and the thing swapped over. And then through the spring and summer of '79, we delivered the microprocessor-based fruit machine contract in the daytime, and here we are again, back in the evenings. We worked to evolve Sophie's Hawk design into the System 1, which I guess we launched not many months later. Would it have been March '79 March or April '79 that appeared in Wireless World, I think.
Like that, yeah.
And so we had the two businesses running side by side, as it were.
Right.
And of course the system boards were quickly complemented with graphics, a graphics board and a memory board, and then we did the rack-mounted systems, which of course was tremendously valuable. I mean, one thing that people will always tell you in the technology industry is there's a mantra. The Americans have an expression, I think, called "eating your own dog food." So
Right.
what that means is you should be using the systems you're developing with,
Okay.
and that way you're getting them. You know you're getting them right.
Yeah. With it.
And of course they get developed. So any improvements, enhancements you make at all to the software or hardware that you're using gets reflected back straight into your own products instead of patching up a third-party development system that you're using. So we built the system computers, the 6502 based Eurocard systems. You've probably seen pictures of them. System 1, and then there was 2, 3 and 4 that were rack mounted with disk drives, and a lot of these were based on developments of Steve Ferber's own home computer system.
Right.
Those were the systems we used to support the development of our small monitor kernels. I was going to say operating systems then, but that would have been premature. The early versions of BASIC, Sophie's Basic Interpreter, and of course we did the word processing, and kept lists of accounts and used them as typewriters as well, and that then led us from the systems into the Atom and so on.
Right.
So that I think is the sort of a early engineering story.
I mean, so what was it like at Acorn in those early days? What was the atmosphere?
Well, you went home briefly to sleep and turned up again pretty promptly in the morning. We were in the offices in the Market Square by then, above the electricity board showrooms, and it was in operation pretty much night and day because we got people around like Nick Toop and Steve Ferber, Sophie Wilson and others who were, some of them still meeting university commitments and so on. So I was very much the daytime shift really. I'd be there from sort of 8:30 in the morning till sort of 6 o'clock in the evening, and a fairly regular working pattern.
Right.
But a lot of these other guys would turn up having completed their studies or PhD work or whatever for the day, and they'd work through the evenings, and it was quite common to come in the mornings and find things completely different to the way you left them the evening before.
The night shift had changed everything.
Yeah, that's right.
So I mean, people really wanted to be there. This was a passion for everybody.
Oh yes, and a phenomena I remember that carried on. We moved from the Market Square to the building at Cherry Hinton that we redeveloped. It was originally belonged to Cambridge Water Company. We developed that as our offices, and then we were in porter cabins around that, and then we built a new purpose-built building for R&D at the back, the so-called Silver Building. I believe it still stands there. But right throughout that time, people, young guys who were interested in computers and who were around Cambridge would come knock on the door and say, "What would you like me to do?"
Yeah.
And I remember very distinctly, as a more mature organisation later on at the Cherry Hinton, the Fulbourne Road site, I remember sitting as chief engineer, sitting with our technical director and advanced R&D manager and a couple of other guys, trying to, as we endlessly were going through lists of the by then 200 R&D staff we had, and working out who was doing what and who was on which project and so on. And there was a name there that none of us recognised, but it had come down from personnel. So we looked at each other and said, "Well, who recruited this guy? Who owns him?" And it turned out none of us had. And we went to, we picked the phone up and called personnel, and Debbie said, "Oh, well, he'd been working here for some months, and then he complained he wasn't getting paid, so we put him on the payroll, and this guy was, I don't know, writing a language interpreter or something and doing a fine job for us." So, no, seriously, so a lot of people in Acorn with, were self-recruited
Right.
because there was such a buzz around the town and around the computer lab, and people just turned up and started work. So we had a tremendous depth of human resource, and of course, people like Andy Hopper in the computer lab were sending people our way. So you know, people like Mike Muller and Martin Jackson. Alan Wright, Ram Banerjee. I mean, these guys were all sort of coming towards us, you know.
Yeah.
And later on, I mean, when we were developing the BBC Micro, and in particular the operating system, there were bits of that being written all over town.
Right.
And Paul Bond, who was leading the operating system, the MOS we called it, didn't we, for the BBC Micro, had a virtual organisation of probably something like 30 software developers who were around the town, all writing different drivers and so on. So it was,
So,
I mean, very, very vibrant, you know.
It sounds like it. I mean, Cambridge itself. Cambridge is. I like to think of Cambridge as our Silicon Valley. So much sort of technology has come out of Cambridge and still does. What was it like at the time? I mean, you've got all these. We know that there was a huge interest, a massive passion in computers and the emerging market that's coming in. What about the town itself? Well, did you have relationships with other companies that started to emerge in the 80s, or
not
was
so
it
much? Not
secretive?
so much because a lot of the engineering companies in the town were still very, very connected with the Pi group. Pi Telecommunications probably being the biggest one, and that was very sort of old school, if you know what I mean. Large vertically integrated companies with worldwide sales forces, their own manufacturing. There were competitors, of course. Tangerine. And Computers, and,
the links,
the Dragon, I think, which appeared, and so on, and of course Sinclair. But I mean, they were competitors, so you kept away from them, and we were, I suppose, really. I mean, I was going to say we were isolated, but we were it. That was the point. I mean, we were.
You had your own world,
but we were the driving force.
Right.
So, and I think, thanks, in no small part to Herman's inspiration and leadership, and the rapport and the style of the company and the people we had. I think we were the company that that the others were all looking at. So I don't remember too many distinct relationships other than with vendors. I mean, obviously, component. A lot of the chip companies. The Toshibas and Hitachis. There's a lot of Japanese memory coming in the early 80s, and TTL, so TI and National Semi and all of those guys. I mean, Motorola, they were all over us. So I mean, we were beating semiconductor sales reps away, and people wanting to make PCBs for us, and we were quickly seen by the supply chain as having a lot of potential, and everybody wanted to come and win our business.
And there was a huge number of third-party developers as well in Cambridge, wasn't there? So, writing software and then starting, I mean, we're going on a little bit of a step, but when the BBC sort of took over the market.
Yes, I mean, Kim Spence-Jones would be a classic example of that. I mean, first of all, he was on the team working with Paul Bond doing the software, I think, for the cassette interface, which was Kim's code, and then rather than, I'm sure Kim had the option of signing on and coming on the payroll, but he decided then to go it himself, and he formed a company called SJ Research, which specialised later on in supporting the Ethernet with Ethernet peripherals and file stores and so on. Another example would be Alex Van Summeren, I think, who worked for us for a while, and then founded Encipher. Martin Jackson, who I mentioned earlier, I think Martin worked on the tube interface. I may be wrong about that, but he then went off to found Tadpole Technology, and then I had the pleasure of working with Martin later at Verata, where he was CTO. As you say, not everybody came in, but everybody kind of stayed.
But it's great looking back through the magazines. You look back through the old magazines at the time, and you look at all these adverts, and there's so many sort of development companies writing software and interfaces and things like that, based in Cambridge is incredible.
Well, that's
But,
right, and that, of course, was without the dealer network that later sprang up as well, and all the third-party developers like Watford Electronics, people like that who were producing things.
So all that was the 80s, and it was sort of the time of yuppies and everything else, and wine bars and everything. You were busy working, were you, or taking part in that as well?
Well, we had to help the marketing guys sometimes.
You leave it at that. Okay, so the BBC Micro in particular, what role did you have in developing that?
I think it's fair to say that I owned the overall design. The way it worked was I was the if you like, the person that sat between Richard Russell of the BBC, Steve Ferber, the sort of system architect of the hardware, Sophie, of course, Paul, others, Alan Boothroyd, who did the industrial design of the case. I was the guy who got it to all fit together, really, and in particular I owned the overall circuit diagram. So after Steve came back from the Christmas break with the sort of first proton circuit diagram of this is how we can do the memory and get the DRAM refresh to be done by the display, so we don't need a separate refresh controller if we break the processor cycles down into this half of the cycle is for processor access and this half is for display access, and that's the sort of heart of the architecture. And I essentially started to draw that up into an industry standard circuit diagram style, and sort of putting part numbers and a parts list together and so on, and working out a profile for a circuit board that would fit in Alan's case, and dealing with all the sundry connections all around the outside, working out what kind of connectors we could use for printers and RS-232 and analog interfaces for joysticks and so on. And essentially, tying all the wires together and getting the thing into a state where we could get a printed circuit board laid out, and we knew what bits went where.
So taking that sort of heart of a design and then producing it into something that you could manufacture and repeat.
Right. And so there were bits of the design around the periphery that were mine. I mean, famously, the integration of the Teletext Decoder, video chip, which was one of the decoder set that Mullard had produced, which I'd first come across at Pi TVT, and so I knew the part, so I picked it up and used it. It was quite entertaining, really. Mullard had a set of chips that you made a Teletext decoder from. The SA and the video chip was the SAA 5050, but there was a 5040, a 5030, and a 5020, and together they made a Teletext decoder. And of course, later on, they were getting all these orders for thousands and hundreds of thousands of SAA 5050s, but don't you need the rest of them? No.
So the rest was all done with your own hardware.
Well, we didn't. It wasn't a Teletext receiver,
Right.
It was just the video chip. But anyway, that needed a 16 megahertz clock, and of course all the clocks inside the micro were a power of 2. I think it was 16 megahertz it was all running from, and Steve was thinking we needed to sort of put a phase lock loop in there and get up to some common multiple of 16 and 6 and then divide back down, and I sat and thought about it over the weekend and said, well, if we clock this off that edge and that off this edge and then throw that one away and add that one in and then put it through a flip-flop to get the mark space ratio back, well look, I've made 16 megahertz, so and that little bit of logic design went in there.
Right.
But other things, the floppy disk interface, and I was involved in hooking up all the Ethernet interface and things like that. So so lots. So there's quite a lot of the circuit design is made around the outside. But then importantly, of course, we needed things like test equipment. So and we had to introduce this design into high volume production lines who needed to know what they had to do to test it before they could ship it, and you had to be very prescriptive about which manufacturers' components were approved. So we had to have approved vendor lists and parts lists, bills of material, and test procedures, and so all of that stuff was was fine. So
Right.
the engineering, if you
Yeah.
like. Yeah.
Great. I mean, and everybody knows it's a brilliantly engineered piece of equipment. So, you know,
I would change almost everything if I had my time again.
hindsight's a wonderful thing.
I'm
but
particularly one thing I'm particularly disappointed about was on the large circuit diagram, an A0 circuit. Well, you've seen it, the circuit diagram, of course. It folds out of the service manual and so on. I had three, and I took great trouble to draw the circuit diagram the way it was on the board. So it was very clear that as you looked around the board or around the product, you were looking around the circuit diagram. So it wasn't just a meaningless mash of wires. You know, the topology of the circuit diagram matched the topology of the product, which made it easy for people to think about it and understand it. But we had all the address map decoding over on one side of the circuit, and on the other side of the circuit I had three areas of memory, which were the ROM and I/O spaces in the memory map. And these were, I think, just a 256 byte, three 256 byte spaces, and they were coming from the circuit diagram from one side to the other, and for completely random reasons. I wasn't going to draw three wires right across the circuit diagram for no particularly good reason, because I wanted to focus on the bus structures and everything. So I put these three wires and put three arrows off them, called them Fred, Jim and Sheila, and then over on the other bits of the circuit, other side, Fred, Jim, Sheila. What a lost opportunity for more humorous nomenclature. I could at least have called them Chris, Stephen, Sophie, or Cambridge. I don't know, but
well, it's on film now. You have that regret and you wish you'd called it that. Even so,
and there are certain choices around the joystick connector and so on that I think we could have done better with as well.
But there are a couple of minor things in comparison with the whole project.
Of course, we got the thing into production, and we fairly quickly iterated through the first few thousand units and the first full revisions of the circuit board as well. And so I think by the time we got the issue for full circuit board, it was starting to become quite a stable machine. The other key contribution that came in was the introduction of the switch mode power supply. It wasn't a technology that was available to us, and we were trying to make a standard linear power supply transformer and regulator work in the box, which we couldn't meet the energy and heat constraints that were required. And we had a very good relationship with a company from Hong Kong called Aztec, who provided the UHF video modulators that we used to get onto the TV. And of course these guys made switch mode power supplies as well. So I wrote up a spec of what we needed, which was basically this many volts and this many amps in this form factor. And they took one of their designs and produced a prototype for us, and I flew over to Hong Kong, my first trip to Asia, with one of our early prototype machines, and we screwed the power supply in and it fitted, and I went back, sat there for a day testing the machine and running it and being as cruel to this power supply as I possibly could, and it all seemed fine, so I signed it off, and a few weeks later we had the switch mode power supplies hitting the production lines, and at that point the quality of the machine was tremendously improved.
Right, fantastic.
Lots of things like that went on.
Just sort of minor enhancements to the machine here and there. So.
Yes, yeah. In fact, I remember making a very similar trip later on to VLSI Technology, who did the two CMOS logic custom chips that replaced the Ferranti parts that we were having problem with meeting the performance spec, and similarly flew out to California with a BBC Micro. Quite entertaining getting it through customs, because I made the mistake of when the customs officer at immigration asked what it was, I said, well, it's something like an Apple. And an Apple II, and of course he thought that I was trying to bring in some grey import or something, so I had to spend some time explaining, he said, no, there's not an Apple product or even a rip-off, it's a genuine.
Completely different.
And why I'm here, and eventually got it through, and again went down to VLSI Technology and plugged in the first the first chips that they made for the video processor, and which worked first time so long as we inverted one wire and I found a spare gate on the board and a wire link to do it, so we could take the chip as was instead of having to spin it,
Right.
which obviously saved quite a few weeks.
Yeah.
And similarly, they pressed the button straight away for us and ran some wafers, and we got those chips down on the production line just a few weeks later as well. So we had a lot of support from companies like Aztec and VLSI Technology and many others, that Hitachi with DRAMs.
Yeah.
We had, you know, some of the first DRAM. We
Yeah.
were prioritised, I think, of production for the DRAM part that we needed, and you know, a lot of vendors and suppliers really contributed, and you know, earned the right to carry on being our suppliers and partners for many years.
Mm.
So that was good.
Yeah, I think I read an article in one of the early magazines about, you know, Acorn in the early days, and there's a quote in there saying a very nice man from Hitachi come and delivered some of the very first chips just to get that prototype off the ground. And
Bob Daly, I remember him very well.
right.
Bob, if you're watching this, hello and thank you.
So I mean, it's also said that the BBC, from its prototype as whatever situation it was, as a proton, not as the proton.
Mm-hmm.
When you sort of found out that the BBC were visiting and you needed to have a machine up and running for that,
Mm-hmm.
Apparently it was basically 4 days that you had to get it from where it was into something that you could demonstrate to the BBC. Is that about right?
I think
And if it
so.
was, what were those 4 days like?
Well, chaotic to say the least. We got a wire wrap prototype put together with. Again, it was you know, very much an all hands thing, and in particular, I think a guy called Ram Banerjee, who was again in the computer lab at the time, came and helped us with wire wrapping. And I see you've got my photograph of Steve and Alan Wright and a third person, and I can't place who that third person is. So again, if you're watching, do let me know. With the you know, actually sitting at the prototype, just bringing what looks like Mode 7 into life. And that was all done actually on my desk, because it was about the only clear space left by then in the Market Square premises, and so.
Because obviously at the same time you were building and shipping out atoms as well. So
well, we were, and I have to say actually that I had a relatively small part in the production of that first prototype, because you know, we did have the daytime business to run of, you know, shipping systems, shipping atoms, probably still System 1s at that point. So I was very much, you know, playing a support role, for instance, trying to get all the bits, you know, just gathering all the components and making sure we got, you know, probes for the oscilloscope and power supplies, and just, you know, keeping the machine running. And then, as I say, you know, a lot more went on in the evenings. My daughter had only just been born, so I couldn't stay that late in the evenings at that time. So it was very much Steve and Sophie and, as I say, Alan Wright, Ram, and one or two others who got that working in 4 days. And you know, there is this absolutely true story that it wouldn't spring into life. I mean, the terrible thing about these microprocessor systems, of course, is if the processor doesn't run, virtually everything in the circuit can stop the processor running. And until you've got a running processor, it's very difficult to test. We had in-circuit emulators, you know, ribbon cables from a host system that we could plug in and probe around the memory map and things like that. But it was quite hard to get the machine up and running, and we couldn't. And Herman was, you know, being tremendously encouraging. And I have to say, I've realised since that Herman personally must have absorbed an awful lot of pressure himself that he didn't pass on down to all of us. But you know, clearly was there night and day, encouraging everybody, and you know, making tea and fetching pizza and making sure that everything, you know, all the shoulders were to the wheel. And he was sitting there, and Steve and Sophie couldn't get this to spring into life. And there was this debate about, well, maybe the host system is holding it back, and Steve said, well, it can't possibly be that. And Herman said, well, can we just unplug it to be sure? Oh, well, if you must, but it won't make any difference. And of course it worked. And this infamous tale of Herman, you know, causing the thing to spring to life the evening before the BBC visited is there in the annals of history now. And then, of course, they came, and really their visit to the machine was very quick. I think it was David Kitson and John Radcliffe and Richard Russell who came, and John was the producer of the programme, the innovator of the whole idea. David Allen probably was there as well. I think it was the four of them. David Kitson was the design engineering manager, and Richard Russell was the person he'd appointed to actually, lead the BBC's efforts. And as you probably know, they'd been trying to work with somebody else and not getting to where they needed to be. And so they were in the market, as it were. And they very quickly looked at the machine really and were impressed with the people and what they saw, and then disappeared down into the office with Herman and Chris to talk about the company and the future of the company and so on. And meanwhile, of course, Stephen and Sophie carried on, let's add a bit more code to this, let's see if this works, and by the end of that day it was, many times more functional than it had been that morning when they first looked at it. And after that, the course was set really.
Right. Fantastic.
I think for me personally, the thing that I'm happiest with really is the fact that, as an electronics engineer, I was privileged to be a part of this and to work of it. I'm very proud of the fact that the work we did is so visible and still highly thought of, because
Absolutely.
After all, a lot of engineers can work their whole careers and do some great stuff, but it never gets captures the public consciousness.
No, that's right.
So it's very rewarding to see that people are still interested in our work after 30 years.
Yeah, absolutely. I mean, this is a big part of the museum, is making sure those backroom boys, those unsung heroes, or whatever, do get credit for those things that have changed our lives. I mean, you've got to look at the home computers, not just Acorns, the Sinclairs, and the all of them out there.
Yes.
That they have completely changed the world that we live in.
That's right.
And you've played an important part of that. So, towards the end of Acorn, how did you leave Acorn before sort of the Olivetti takeover, or was it after?
Oh no, I had quite I was quite involved through all of that. You know the story of how we came to be an Olivetti company, and at that time the company was reorganised into 4 divisions, and I ceased to be chief engineer of the whole company and had a position, I think, as operations director in what was called our custom systems division, where I worked with John Horton, and we ran that for 3 or 4 years, and that was the time when I was also Acorn's project manager for the Doomsday project.
Right. Okay.
Some variants of the BBC Micro. We did a version of the BBC Micro on a card in a different form factor for an OEM customer and things of that nature. And then we continued to have some business issues, and the company was reorganised and downsized yet again. And that was when I did leave Acorn, and I'm pleased that I was invited by Andy Hopper to join the Olivetti Research Laboratory that he was just setting up in town, and was able to go there and contribute for a few years until joining one of the spin-outs that came from there, Verata, a fabulous semiconductor company where we made broadband modem chips.
Right. Yeah,
and,
absolutely.
So that was good. So I was really there for the first half of Acorn, because of course the company then went on for another 10 years. ARM had already spun out by then, by the time I left. And I suppose one of the things I still, perhaps many of us think about, is it's a shame that there isn't still a big headquarters building somewhere in the town with that green acorn over the top.
Oh, absolutely.
We haven't still got the company here, but you know what? In fact, we have. Only it's called ARM and not Acorn, because when you sit back and look at it, that's the continuum of our technology.
Absolutely.
And what we were trying to achieve technically.
Yeah.
Only now it's all inside the mobile phone and other places.
Which is a hugely important part of our lives. So
Exactly
it's a great thing.
Yeah.
Well, thank you very much for your time. Really appreciate it.
You're very welcome.
It's been very interesting, and good luck with everything you do in the future.
Okay. Well, thanks very much.
Thank you.
Mm-hmm.